Hello guys, we're just going back, and remember in the previous video we actually had a case when the problem doesn't have solution, right? It didn't have solutions because there was discriminant was actually negative. That was actually meaning that no solution for our quadratic equations. And the reason was in that the distance between them, between two flagpoles, right? That wasn't actually enough in order to arrange this rectangular shape here. So I just reset up 40 meters apart instead of 15 as in the previous case. You see that now the distance is 40, and we keep all our decisions like that we made before correct. So one more time and just recap what actually we did. So we set up x, right, the small side, the small leg of the small triangle, and hence the rest part, distance between the x coordinates and another flagpole is 40 minus x, so basically the whole segment minus x. Then we decide to arrange two Pythagoras theorems for each triangle, so that's how we express height 1 squared. Height 1 squared is this one, so it's root 10 in x. It's not changing. But height 2 squared, due to new distance apart, 40 meters, we actually need to set up 50 minus x instead, 40 minus x. Okay, and hypotenuse 2 as actually was that side. So we arrange hypotenuse 2 squared equals 10 squared plus 40 minus x squared. Now we need to add, and if we add two hypotenuse, so maybe I better write this way. So if we add height 1 squared plus height 2 is also squared, we'll get that side which is hypotenuse. So right now we consider that triangle and we apply simply Pythagoras to it. So we add up two legs which are squared, we add the squares of two legs, and that's how we arrive to this blue line which is also 40 meters. So we've got 40 meters squared. In this case, for this triangle, it's hypotenuse. Okay, so let's see what we've got finally. If we add them up, we can get the following equations. So 40 squared, that's left hand side, if we add two hype squares. So on the right side, we've got x squared plus 10 squared plus 10 squared, which is plus 200, okay? And then I expand the brackets here. So 40 minus x, I'll get 40 squared minus 2 times 40 is 80x. I use the formula, the shortcut, so make sure you understand how it works. So in the previous video, I actually told you that it's a squared minus 2ab plus b squared, that how the formula a minus b squared works, okay? And I use it there. All right, now what I'm going to do, I'm going to cancel when I expand the brackets, because now I don't need any brackets, so I can cancel 40 squared and 40 squared without any calculating. You see how you save your time. So and now I've got the following. So if I simplify what I have, I'll get x squared. So x squared from here, if we add them up, we'll get 2x squared. Then I negative 8x, negative 80x goes, and then plus 200, it stays alone as the free number, free coefficient. Okay, so if I divide by 2, I'll get x squared, next minus 40x and plus 100, that what I got equals to 0. So I cancel by 2 by dividing. And now I see that discriminant in my case, it's 40 squared minus 4 times 100, which is 400. So in this case, I will simply get 1,600 and minus 400, which gives me 1,200. So 1,200. From where I can set up the equation for final x in order to find x, and I'll get 80 plus minus square root of this number. So square root of discriminant. That makes me square root of 1200 and over 2. Okay, so let's estimate first with the positive. Obviously positive works every time. So square root of 1200, okay, and the whole thing I'll divide by 2. That gives me round 57.32 meters. Okay, so rounded to 2 decimal places. Okay, so what about x2? If I try to figure out solution with minus, in this case 80 is more than square root of 1200, because if you raise up 80 squared, you'll get around you'll get 6,400, right? In this case, it's more than 1,200. So with minus, I'll have also the possibility in order to fix the solution. Okay, so I've got the second one, which is 22 with minus, and 68 if I round up to 2 decimal place. Okay, so what we are asking in this question, we need to find the distance between the nail and the nearer flagpole. So nearer flagpole, the nearest to the nail, which have the lowest distance, it's here. So that's why the final solution will be 22.68. Okay, so that how it works, and that how we got the solution out of 2. Alright, so hope you got it, and we're going to move next. So that's the whole solution for the problem number 4. Okay, so let's move next. So what we have, I just erase that we don't need. Okay, so let's see. You have rectangular fields is enclosed by, okay, so by a fence, but the total length of 50 meters. The area enclosed is 120 square meters. You need to find dimensions of the enclosure. Alright, so what this page is about. So rectangular field enclosed by the fence with the total length, so here is misprint, with the total length of 50 meters, okay? That rectangular field, which is enclosed by the fence. So that's the field here, and it's closed with the total length. So basically what we have a perimeter of the length of the fence. So perimeter is actually 50 meters. So the area enclosed is 120, so we've got area inside, which is 120 meters squared. So you need to find dimensions of the enclosure. Alright, so if we have dimensions as A and B, we know that, first of all, let's work out area. So the area is simply A times B, is the area of rectangle. So the first one, and hence we can set up the first equation. That's A times B, which is 120 meters squared. Next, about perimeter. So perimeter is the sum of all 4 sides of this rectangular field. So that's why here we need just to add all 4 sides. So but we have couples, 2 A's. So perimeter is simply 2 A's and 2 B's. You don't need to memorize, you just need to understand that perimeter of any shape is just the sum of lengths. So some people used to memorize every single formula, but guys, just keep your memory free. Otherwise, you'll be lagging. Okay, so in this case, perimeter is simply 2a plus b. I just factorize, okay? Or you can leave as it is no matter how you use that. So let's leave as it is. So 2a plus 2b will be equal to 50 meters in total. So hence we set up the second equation. So 2a plus 2b, which is 50 meters. And right now we are going to solve the simultaneous equations. So we need to find a and b as dimensions. Okay, so let's do it. So we got a times b. And from the second equation, so we set up the first, and this is the second one, how to solve system of equations, you just simply express one value, one variables for another, let's say a through b. Okay, but before I just simply divide by 2, so that I get a plus b equals 25. It's easier. Now I just want to express a through b. A is 25 minus b, and then I substitute. So that's the method, what is called substitution. You can also use another method which is called elimination. So in substitution, you just express and put instead of a the right side of the expression for a. So you'll get 25 minus b times b, which is 120. And now you just simply solve the first equation. You left with one variable b. Before you have both, right, a and b. Okay, so another method is elimination. In this case, it doesn't work well. Yes, elimination works when you have linear equations. Okay, that's the best way you can apply that. So here we express, and obviously we've got quadratic equation. So let's expand the brackets. So we've got 25b minus b squared and minus 120, because we need to collect all the items in one side. So, but I don't like when we have, you know, the leading coefficient with minus sign. So I transfer everything to the right hand side. So I got b squared minus 25b, swapping the sign to transfer, and I've got the final quadratic equation. Okay, so let's see what I've got. So 25 squared, so I use discriminant. So discriminant is 25 squared, which is 625 minus 4 times 120, which is 480. So let's see. So 625 minus 480, I've got 145. It's good, it's more than 0, so we are going to have solutions in this problem. And finally, let's calculate the b. So b is 25 plus minus square root of discriminant. I use the quadratic formula. Square root of 145 and over 2. So in both cases, we have like two solutions. So b1, I've taken the plus. So let's take the plus. So we've got 25 plus square root of 145, and then everything divided by 2. Okay, we've got everything divided by 2. So b1, if I use with the plus sign, I've got 18.52 to 2 decimal places, 2 dp. Alright, what about b2? I use the minus sign, and I know already that it'll also be positive. So first estimate if it's negative, it doesn't work because side dimension cannot be negative. So in the second case, using the minus sign here, I'll get 6.48. Okay, so 52 here, and the second solution is that one. Okay, so because we have only solution for b, we need to find solution for a as well. So which equation to use? Of course, where you expressed a through b. So we know that a is 25 minus b. So we simply to put in and say, okay, so better transfer it there. So we just use 25 minus b. And we write, okay, a is 25 minus b. And now we need to plug the first b value, which is 18.52. So we subtract. So 25 minus 18.52. I've got the value for 6.48. Okay. And when I do the same with the b2, I'll get 25 minus 6.48. So A2 is 1852. All right. So that's what I've got for A2. And the answer, you need to state, okay, so if B value 18.52, so A is 6.48. So, or you have another solution with another b, another a. Okay, so use that two values as the solution because you need to find dimensions. All right, so that's the solution for the problem number 5. Okay, so I hope you got it. Hope you enjoy, and don't forget that we just need to finalize all other tasks. That's actually a lot of here, so you can pause the video, try to make them all, and then try to compare with my explanations and with my solutions there. All right, so and 11. So yeah, we need to cover all that problems in the nearest time. Hope you enjoy, and see you later.